All right, as we wrap up the first half of the semester, we're going to work on some trigonometry, looking specifically at some of the basics. In the last session, we went over the definitions for the trig functions, and you can look those over if you need to. Today, we're going to look at actually evaluating some of these measurements. Now, sine of 48 degrees, again, what that means is that's some number that when you have an angle that's 48 degrees, the ratio of the opposite to the hypotenuse will be this number. So let's just look at putting that into our calculator and see what happens. Now in this particular calculator, it's a pretty dumb calculator, so I think I have to hit 48 and then I hit sine. And that gives me a number, 0.743144825477,394. That is the ratio of the hypotenuse to the opposite side, the opposite side to the hypotenuse. Any triangle that has a 48-degree angle in it, whatever the opposite side is, the hypotenuse will have to satisfy this ratio. One thing I want you to notice here is the little DEG in the left-hand corner. That is important. Make sure that when you're doing this with a calculator, you are in degrees. For example, if I had done sine of 48 and I were in radians, which we'll get to later, I would have gotten a very different number, -7 or -0.76 and so on. So make sure your calculator is in degrees. Now with this ratio, all the ratios for sine and cosine, all the outcome values possible are going to be between -1 and 1. And since that's a pretty limited target area, we're going to want to use as many decimal places as we can. So let's say I hit 22 by accident. Let's redo here. 48 sine. Looks like that's going to be 0.7431. You want to take it out at least 4 decimals. Always use at least 4 decimals. That will get you a good enough approximation. If you start doing some sort of surveying exercise and you take it out to just 1 decimal or 2, you might be 2 or 3 feet off, which is liable to upset a landowner somewhere. So you want to go ahead and use as many decimals as you can. 4 is a minimum, and I think 4 is pretty much adequate. All right, let's look at another one. And tangent of 67. Again, we'll just take 67 tangent. Now, tangent outcomes can be anywhere on the spectrum. It can be any real number. So getting a 2.35585 is not that surprising. Let's see if we can get this so that, there we go. Okay, so again, we'll go ahead and let it round to 4 decimal places, 2.3559. Now, all of these functions, like I said, they're ratios of one side to another. They don't have any units. It's just a number, 0.7431, 2.3559. It's not like .7431 square meters or anything like that. All right, we'll do the same with cosine. You get 0.857167, etc., which we will round to 0.8572. Now, I said my calculator's old and does things a little strange. On many of your calculators, you will have a button that says sine, and when you put in sine, it'll pop this up, and then you would just type in 4, 8, and then you can either hit enter, or if you've got more stuff to write, you can close the parentheses and whatever else you need to add. All right, I think that's it for the sine, tangent, and cosine. What about this other stuff, this sine with the -1? We say that as the inverse sine, and what that means is the angle that would give us this outcome as our, if we took sine of that angle, this is the number that would come back. Again, on many calculators, you're going to have a shift button or a second button, and then you'll hit the sine button and it'll come up like this, and then you put in whatever you want to. 0.9751, and then you'd hit enter. On the calculator that comes standard with my computer, I have to hit second, which changes all the buttons. And now I have this inverse sine button, so I'll do 0.9751, and I'll hit the inverse sine button, and it tells me that that is 77.18727, etc. degrees. We will abbreviate that with, I need to remember not to hit buttons before I'm ready. 0.9751 inverse sine. And now I'll bring it down here so I can still see it when I go to punch it in. All right. That's going to be 77.2 degrees. All right. Now let's try it again with the tangent. We take 0.4137 and we hit the inverse tangent button. Tells us that an angle of about 22.5 degrees will give you a tangent of 0.4137. Degrees you can abbreviate about 1 decimal point, perhaps 2 if requested. The last one, 0.7442, inverse cosine, that tells us that an angle of about 41.9 degrees will have a cosine value of 0.7442. All right. Let's see how we use this. Let's say you have a triangle. You can pretend it's a right triangle. And you have a resistance of 407 kiloohms. and a reactance of 732 kiloohms. What is the impedance? And what are the two angles, phi and theta? Well, we know how to find the impedance with our Pythagorean theorem. We'll just punch in 732 squared plus 407 squared equals, and then we'll take the square root of that, and we get an impedance of 837.5, or rounded appropriately for your problem, for your exercise. Now, how do we deal with the theta and phi? Well, I like to use numbers that were given to me, if at all possible. So since I was given the 407 and I was given the 732, I want to use those numbers and come up with something that relates those two numbers to theta. And what we know is the tangent of theta is going to be equal to 732 over 407. Now, what does that mean? We just learned that if we take the 732 divided by 407 and use this inverse tangent function, that will tell us what our angle is. So 732 divided by 407 equals, and now I will hit my inverse tangent, and it tells me that's about 60.925 degrees. So 60 degrees, 60.9 theta is approximately, I'm going to use this approximately because this is not exact, 60.9 degrees. Now for phi, we could do the inverse tangent again, except this time putting the 407 over 732. However, we can also remember that phi and theta together will add up to 90. So I can just subtract 60.9 from 90, and I will get phi is 29.1. Okay, that was if we were given two legs. Let's try another one. Triangles that you also see are in Siemens. And we've got Y up here, G down below, B on the side, and phi and theta remain in their respective positions. Let's say B is 8.2 microsiemens and theta is 25.9 degrees. Let's find the remaining data, the remaining elements of this triangle. We know the one angle is 90 degrees. We know theta is 25.9, so we can quickly deduce that phi is going to be 64.1 degrees, a simple subtraction of 25.9 away from 90. How do we find what y and g are, though? Well, we need to find something that ties together the b and the theta, and let's do y first, and y. Well, in our trig functions, we know that sine of theta is going to be b divided by y. So if we plug in what we know, that gives us sine of 25.9 degrees is going to be 8.2 microsecond or Siemens divided by y. If we multiply both sides by y and divide both sides by the sine of 25.9, we get y equals 8.2 divided by sine of 25.9. Now you could probably, your calculator's smarter, you can probably just punch in 8.2 divided by sine 25.9 close parenthesis equals. Again, mine's a little archaic. I'm going to do 8.2 divided by 25.9 sine equals, and I get a value for y of 18.77. Alright, I'm going to put in y is approximately 18.77 microsiemens. At this point, I could use the quadratic formula, Pythagorean theorem. However, I would be basing my answer on this approximated answer, and I don't like to do that. So what I'm going to do instead is find a trig function that is based on theta and b and g. And that trig function would be tangent. Tangent of theta is going to be b over g. And just plugging in values, we get tangent of 25.9 is going to be 8.2 over g. And solving like we did the previous one, g is 8.2 over tangent 25.9. And dropping that into our little calculator, 8.2 divided by 25.9 tangent equals 16.887, which we will write as 16.89 microsiemens. Now, the question I have for you is, do these answers make sense? Let's look first at our angles and sides. This angle is 25.9. It should go with the shortest side. Well, 25.9 goes with 8.2. 8.2 is the shortest side. Then we have an angle that is 64.1 degrees. It should go across or correspond to the middle side, 16.89. That seems about right. And the longest side should correspond to the hypotenuse. Always make sure your triangle makes sense. If you end up with a longest side across from a smaller angle, you need to go back and clean that up. That should be enough to take care of 7b. Don't forget to do your practice review for the midterm. Hopefully by now everyone's gotten their midterm proctor arrangement. Practice review for the midterm. Hopefully by now everyone's gotten their midterm proctor arrangements to me. And best of luck on that. We'll talk to you later.